This is part 1 of our lesson on solving polynomial equations. So before we actually start solving equations, we're going to take a look at a little bit of quick radical review. So a radical is just another name for a root. So it could be a square root or a cube root or a fourth root. And in grade 11, you would have learned a little bit about how to do some operations. I'm just going to focus with radicals. So I have 2 root 5 plus 10 root 3 minus 8 root 5. So when you are adding and subtracting radicals, we would collect like terms. Like terms are things that have the same root part. So if I look at 2 root 5 and 8 root 5, they both have the same root 5. So that's going to make them like terms. So I'm going to take 2 root 5 minus 8 root 5 and then subtract the coefficients. So 2 minus 8 would give me negative 6 root 5s. And then the 10 root 3, unfortunately that has a different number under the square root, which means it is not a like term and it's going to stay by itself as 10 times the square root of 3. So this would be negative 6 times the square root of 5 plus 10 times the square root of 3. For our second one, we are going to do a little bit of multiplication and division. And the focus button, oh, there we go. I'm like, it wasn't working before last time I pressed it. So this is 4 root 10 times 5 root 7 divided by 2 root 5. So the secret to multiplying and dividing is to do coefficients with coefficients. Those are the numbers in front. And the numbers under the roots with numbers under the root. So I'm going to take 4 and 5 and multiply those together. 4 times 5 is 20. And then I'm going to multiply the root parts together. Root 10 times root 7. 10 times 7 is 70. So this is 20 root 70, or 20 times the square root of 70. And on the bottom, we still have 2 root 5. So when I go to divide, I do the same thing. We do coefficients with coefficients and roots with roots. So 20 divided by 2 would give me 10. And then root 70 divided by root 5, I would just do 70 divided by 5, which is 14. So this would be 10 times the square root of 14, or 10 root 14. Now the skill that we're most interested in today is actually how to write things as mixed radicals. So mixed radicals are kind of like mixed fractions. So a mixed fraction is something like 1 2/3, where there's a whole number part out front and then the fraction part remaining. So what we want to try to do here is something similar. We want to write this as a mixed radical. So I want to look at 175 and see if any part of that is a perfect square. So I want to see if I can find a perfect square that would divide into 175. Perfect squares are numbers like 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, right? So we're trying to find the largest perfect square that would divide into 175. Now, I notice it ends in 5. So I'm thinking that the perfect square might be something related to the number 5. So 5 squared is 25. So if I take 175 and divide it by 25, I notice that it's 25 times 7. So when I was up here, I said when we multiply radicals, we do the number under the root times the number under the root. I'm going to do the opposite of that. I'm going to break apart that square root of 175 by saying this would be the same as the square root of 25 times the square root of 7. So I picked a perfect square because I want something that will actually work out, right? If I chose numbers that weren't perfect squares, there wouldn't really be any point in this. So the square root of 25 is 5, and then the square root of 7 is a decimal, so I'm just going to leave it as the square root of 7. So if I try on my calculator the square root of 175, that's 13.228, and then it just keeps going. If I try 5 times the square root of 7, I get the exact same number. Right? So it's just a different way of showing that root in mixed radical form. Let's try the square root of 320. So I'm looking at 320. I notice that it's an even number. So I'm wondering if either 4 or 16 or 64, so any of my even numbered perfect squares would divide in. And I would like to try to find the largest one that would work. I think I'm going to try 64 first. So 320 divided by 64 actually works out. It's 64 times 5. So I would say this is the square root of 64 times the square root of 5, right? 64 times 5 is 320. The square root of 64 is 8. The square root of 5 is a decimal, so I would just leave it as 8 times the square root of 5. Okay, so you can join me in the next part of the video and we will talk about quadratic formula.